and welcome once again to the topic-wise questions of one more video. Today in this video we will learn and discuss the topic-wise questions of the topic Kc, that is equilibrium constant. Let's start with the MCQs first and then we will go ahead with the subjective questions also. So here is our first question, MCQ. It says, in an experiment, 2 moles of hydrogen and 3 moles of iodine were heated together in a sealed container and allowed to reach equilibrium at a fixed temperature. The container had a fixed volume of 1 dm cube. At equilibrium, there were 2.4 moles of iodine present in the mixture. Now here is our equation which says that hydrogen and iodine reacts together to form hydrogen iodide. Now according to the experiment, the question, it says that the initial concentration was 2 moles for hydrogen and 3 moles for iodine. At equilibrium, the 2.4 moles of iodine were left. That is, iodine is 2.4 moles left at equilibrium. That shows that on subtracting this we get 0.6 moles, that is the used up amount of iodine, used up moles of iodine. Now if we can look at the question here in the equation, it says 1:1 mole ratio of hydrogen and iodine. So that shows that the same moles of hydrogen had been used up. So we subtract 0.6 moles of hydrogen, that is it would be used up. So the leftover hydrogen will be 1.4. Now from the equation we can make out that the mole ratio of iodine is to hydrogen iodide is 1:2. That is, if 0.6 moles have been used up, double of it will be formed. So we need to multiply 0.6 by 2, that is 1.2 moles of hydrogen iodide will be formed at equilibrium. So the moles of hydrogen at equilibrium is 1.4 moles, moles of iodine at equilibrium is 2.4 moles and hydrogen iodide is 1.2 moles. Now we know that the volume is just 1 dm cube, so moles divided by concentration is just going to give us the same answer as moles. So let's substitute all these values in the Kc expression. But before that, let's write the Kc expression. So the concentration of hydrogen iodide should be raised to the power of 2, as we have the mole ratio 2 here, divided by the concentration of hydrogen and the concentration of iodine. Now substituting all the values, we get 1.2 square divided by 1.4 into 2.4, which gives us the answer of 0.429. So our answer is C, which is again 0.429. Let's go ahead with the next MCQ, question 2. The reaction between sulfur dioxide and oxygen is a reversible reaction and the enthalpy value is given here. The question says, which conditions of pressure and temperature favors the reverse reaction? That is, the sulfur dioxide and oxygen should be favored and the conditions required for pressure and temperature. So let's have a look at the equation first. It says that delta H value is negative. That is, the forward reaction is exothermic because delta H has got a negative value. So to understand the effect of pressure, we should know the total number of moles on both these sides. So here we have 2 plus 1, that is 3 moles of reactants reacting and 2 moles of products formed. So we know that there are fewer number of molecules on the product side, and so forward reaction is favored by high pressure because high pressure favors fewer number of molecules. But we have a question of reverse reaction, so we should have a low pressure to favor more number of molecules. So the option A and B gets cancelled off because of the same reason. Now let's have a look at the temperature. Forward reaction is exothermic, so low temperature favors the forward reaction, but if we talk about reverse reaction, then we should have a high temperature. So our answer is C, with low pressure and high temperature. The next question, third MCQ, says 2 moles of compound P were placed in a sealed container. The container was heated and P was partially decomposed to Q and R only. A dynamic equilibrium between P, Q and R was established. At equilibrium, X moles of R were present and the total number of moles present was 2 plus X by 2. Now let's find out what is the equation for this reversible reaction. Now the question says X moles were present for R at equilibrium, and it says 2 moles of P were present at the starting of the reaction. So let's work out for each and every reaction, and let's start with the reaction A. Now A says P gives 2Q plus R. Now if it says R is X at equilibrium, that shows that, and initially P is 2 moles, which is 0 and 0 on the product side. Now if it R is X moles at equilibrium, then the Q should be 2x moles of equilibrium, and P should have 2 minus X, as the mole ratio of P and R are the same. Now if we total up all these moles, then the answer is X and X gets cancelled. So our answer is 2 plus 2X. But total moles should be 2 plus X by 2. Now if we have a look at this line, it is X by 2. That shows that some of the moles should be half of the R, then only we get an answer for X by 2. So let's have a look at the other equations now. Now R is X, so something should be X by 2, that is half of the R. Now if you have a look at the option B, we have double moles of P and Q. Now that is not possible, but we can look later on also if we don't get the answer. Looking at C, it says that same moles of Q and R are present because of 1:1 ratio. So if R is X, Q also should be X, and P should be 2 minus 2X. Again, that won't give us an answer of X by 2. So let's have a look at D. D says it is 2P, Q and 2R. That shows that Q should be half of R. We may get an answer here. So let's work out for this first. And if we don't get an answer, then we will definitely work for B and C. But let's have a look at the option of D first, where it says 2P gives Q plus 2R. Now initial moles of P is 2, 0, 0, and at equilibrium R is X. So X should be, Q should be, X by 2, because it is 1:2 ratio. So Q should be X by 2, and P at equilibrium, we can see that the mole ratio of P and R are same. So if X moles are formed, then X moles of P should be used up. So the P will be 2 minus X moles at equilibrium. Now if we add all this to find the total moles, we can cancel out minus X and plus X, and we are left with the total moles of 2 plus X by 2, which is our answer. Here is the total moles, 2 plus X by 2. So our correct option is D, with 2P gives Q plus 2R. The fourth MCQ. When copper is added to a solution of silver ions, the following equilibrium is established, and this is the equation with a Kc value of 1 into 10 power 5. What is the concentration of silver ions at equilibrium when copper ion concentration is 0.1 moles per dm cube? So before we go ahead, let's write an equilibrium expression for Kc, that is the product concentration first, that is concentration of copper ions and concentration of silver raised to the power of 2. Divide by the concentration of reactants, that is concentration of copper, but as we can see that it is solid, then we don't have to write the silver and we don't have to write the copper also. So we are left with Ag ions, silver ions to the power of 2. Now the question gives us the value of Kc, that is 1 into 10 power 5. So let's substitute that 1.0 into 10 power 5 for Kc equal to the concentration of copper ions, that is 0.1, divided by the concentration of silver ions raised to square 2. So the concentration of silver ions should be concentration of silver ions, which will give us the value of 0.1 divided by 1 into 10 power 5, but as we had seen that it was raised to the power of 2, so to remove it we need to find out the square root of this value, which gives us the final answer of 1 into 10 power minus 3 moles per dm cube. So the answer is C. Let's have a look at one more MCQ. The formation of hydrogen and ethane from methane reaches a dynamic equilibrium and the reaction is given here. What are the units of Kc? Okay, to find out the units of Kc, first let's write the Kc expression, which is product on the top, that is hydrogen raised to the power of 3 into the concentration of ethane with no power, divide by the concentration of methane raised to the power of square 2. So if we work out the unit, we should have moles per dm cube to the power of 3, again moles per dm cube for ethane and moles per dm cube to the power of 2 for methane. Now if we cancel out the units, then we can cancel out this and the power here. So we are left with these two remaining, giving us mole square to the power dm minus 6, which is our final unit for Kc, and so our answer is B. Now let's have a look at some subjective questions also. The first question says hydrogen iodide dissociates into its elements according to the given equation. Write the expression for equilibrium constant Kc, which carries 1 mark. So let's write the expression for Kc, where the concentration of product on the numerator, that is concentration of hydrogen multiplied by concentration of iodine, divided by the concentration of hydrogen iodide and raised to the power 2. Just writing this simple expression directly gives you 1 mark. Now let's have a look at the next sub question of the same question. It says at 120 degrees Celsius, the equilibrium mixture contains 1.47 moles per dm cube of hydrogen iodide. That's the concentration of hydrogen iodide, and 0.274 moles per dm cube each hydrogen and iodine. Calculate the value of Kc. So directly substituting the values in Kc expression, we have concentration of hydrogen iodine in the numerator, that is 0.274 multiplied by again 0.274 divide by the concentration of hydrogen iodide, that is 1.47 moles per dm cube square, which gives us the value of 0.035. So the value of Kc is 0.035. Sorry, this is 5. The next sub question, it says suggest an explanation why it would be more difficult to determine Kc for this equilibrium at room temperature. Now we know that at room temperature iodine is solid. So Kc doesn't include solid iodine, so we can write that it's difficult because iodine is solid at room temperature. At room temperature. Now another reason could be that if iodine is solid, the concentration of iodine is difficult to measure, or you can say that the concentration of iodine will be too low to measure. So this gives you 2 marks, but you can write one more point that at low temperature, at room temperature, the reaction will be too slow. Reaction is too slow, so it is difficult to measure the concentration, and so it gives us difficulty to determine the value of Kc. Now the next question. Alcohols and esters are important organic compounds which are widely used as solvents. Esters such as ethyl ethanoate can be formed by reacting carboxylic acids and alcohols as shown in the equation. The reaction is an example of dynamic equilibrium. Now question A. Explain what is meant by dynamic equilibrium. Now as we have already studied, dynamic equilibrium is where the rate, it's a reversible reaction where you can start it is a reversible reaction in which rate of forward reaction is equal to rate of backward reaction. That's called dynamic equilibrium. But there is one more feature we need to consider for dynamic equilibrium, is that the concentration of reactants and products remains constant. Now we can't write remains same, we need to write remains constant. These are the two features for the dynamic equilibrium which earns you 1 mark. Now the next sub question says that write an expression for equilibrium constant for this reaction. Now if you have a look at the reaction, then Kc equal to the concentration of product, that is the ester CH3COO C2H5 into the concentration of water divide by the concentration of reactants, that is acid, ethanoic acid, multiply by the concentration of ethanol, that is C2H5OH. This is the expression for Kc. Now let's have a look at the next sub question which says, for this equilibrium the value of Kc is 4. So we are given the value of Kc. A mixture containing 0.5 moles of ethanoic acid and 0.5 moles of ethanol, 0.1 moles of ethyl ethanoate, that is ester, and 0.1 mole of water was set up and allowed to come at equilibrium. Now this shows that these are the initial moles. These are set up to reach equilibrium, and the final volume of the solution is VDM cube. Calculate the amount in moles of each substance present at equilibrium. So let's start by writing the reaction first, that is with the carboxylic acid and ethanol C2H5OH, which gives ethyl ethanoate, that is CH3CO2 C2H5 plus water. Now what this says is that the initial concentrations of all this is 0.5 moles, then again 0.5 moles, 0.1 mole, and again 0.1 mole for water. Now we don't know the concentrations of all these species at equilibrium, so let it be say x moles of ethyl ethanoate and water is formed. So at equilibrium it should be 0.1 plus x, 0.1 plus x, and so if x moles are additionally formed at equilibrium, then same amount should be used up from the reactant. So 0.5 minus x, again 0.5 minus x for the carboxylic acid. Also these are equilibrium concentrations. Substituting all these values in the Kc expression will give us 0.1 plus x multiply by again 0.1 plus x divide by the concentration of reactants, that is 0.5 minus x, again multiply by 0.5 minus x, and we know that the value of Kc is 4, which is given in the question here. So if we substitute that, 4 is equal to 0.1 plus x, and now you can write it in the square form. Again 0.5 minus x whole square, and if we want to remove this square, we can take a root of this, which will give us an answer of 2. Now this gives a value of x is equal to 0.3. Now if we substitute the value of x in the concentrations of the products and reactants, then the concentration of ester is it's 0.1 plus x, that is 0.1 plus 0.3, which gives us a value of 0.4. And we can see that the water also has the same concentration, so concentration of water is also the same. Same in the case of carboxylic acid, that is ethanoic acid, and the ethanol also have the same concentration, which is 0.5 minus x. So this gives us 0.5 minus 0.3, which is equal to 0.2 moles for both the reactants and 0.4 moles for both the products, and this is what we have to calculate, that is the amount of moles of each substance present at equilibrium. This earns us 4 marks, 2 marks for the correct expression, then the value of calculation, and then the 2 correct values for each of the reactants and products. Now we also need to note down one more thing, that the volume of the solution was VDM cube. Now to find out the concentration, we need to divide each of these by V, but we didn't consider V because then it gets cancelled out, as there was no units for Kc and no power to any of the expression. So as all the V gets cancelled, and so we didn't consider it during our calculation. So in this video you have discussed 2 of the big subjective questions and few MCQs also related to the topic of equilibrium constant Kc. In the next video we will learn about the questions related to Kp, that is the equilibrium constant with respect to pressure, and also you can see the PDF file for this topic wise questions as a worksheet in the PDF form in the description of this video, and also feel very free to get any free guidance on the given mail ID also.